By the way, again, there is nothing sacred about our choice of why we picked circular functions. We could have picked hyperbolic functions, namely, why couldn't we have started, say, with one branch of the hyperbola, x squared minus y squared equals 1? Given a length t, why couldn't we have measured t off along the hyperbola, say this way if t is positive, the other way if t is negative, and then what we could have done was drop the perpendicular again, and we could have defined what? The y-coordinate to be the hyperbolic, well, we couldn't call it cosine anymore because it would be confused with the circular functions. We could have invented a name, as we later will, called the hyperbolic cosine. I won't go into any more detail on this. See, this is an abbreviation for hyperbolic cosine, meaning this, I'm sorry, I get this backwards. Call the x-coordinate the hyperbolic cosine, the y-coordinate the hyperbolic sine. You don't have to know anything about advanced mathematics to see this. All I'm saying is I could just as easily have taken any geometric figure, marked off lengths along it, taken the x-coordinates and the y-coordinates, and seen what relationships they obeyed. You see, as such, there is nothing sacred about working on a circle. Not only that, but even after you agree to work on a circle, there are many other ways that one could have done this. For example, someone might have said, look at, when you take this length called t, why did you elect to mark it off along the circle? Why couldn't you have taken a radius equal to t, taken S as a center, and swung an arc that met the circle, and call this length t? You see, instead of measuring along the circle, measure along the straight line. Again, you could have done this if you wanted to. Why you would have wanted to do this? Well, you have the same right to do this as I had to do mine. Of course, you have to be a little bit careful. For example, in this particular configuration, notice that if this is how you're going to define your trigonometric function, your input, your domain, has to be somewhere between 0 and 2. In other words, you cannot have a length longer than 2, because notice that the diameter of this circle is only 2, and therefore if t were greater than 2, when you swung an arc from the point S, it wouldn't meet the circle at all. Well, that's no great handicap. It's no great disaster. You still have the right to make up whatever functions you want. I will try to make it clearer why we chose these circular functions from a physical point of view as we go along.